Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We're continuing with Chapter 5, which is quadratic expressions and functions. So we're going to be moving into later. We're going to be talking about solving quadratic functions when things don't factor. So the name of this lesson is called Imaginary Units and Complex Numbers. It's 5.4. And basically, if you remember what we talked about, solutions are where the parabola or quadratic function crosses the x-axis, but it is possible sometimes for those intercepts to cross at weird decimals, or to also not even cross the x-axis. So there are always two roots or two solutions to parabolas, but sometimes if the parabola is floating above the x-axis or below the x-axis, we have what are called imaginary or complex answers, not imaginary answers. We have complex answers, that's what we're going to talk about today, okay? So stick with me. It's kind of a long lesson. It's going to be covered in 2 days, at least for how I'm teaching it when you're watching this video. So just stick with me and bring some questions to class if you have them, okay? All right. So an imaginary unit says not all quadratic equations have real solutions, so we use the imaginary unit I. So we have, the example says, solve x squared equals negative 49. Well, let's go ahead and solve that. So we have x squared equals negative 49. Now, how do I get that rid of that squared on an x? Well, I'm going to take the square root. And you should see we have an issue here. What's the issue? Well, we can't square root a negative number, so this is going to be x equals plus or minus the square root of negative 49. So this is why we have the imaginary unit I. It's kind of like a placeholder. It's kind of like we're not allowed to take square roots of negative numbers, which is why this is a problem. But mathematicians, we didn't let that stop us. We kind of came up with a placeholder or kind of a imaginary number to help us be able to still solve quadratic functions that don't factor and stuff. Because I was looking up some uses for it. It's very useful for electronics and computers and stuff like that. It's a useful tool. So I'm not sure exactly how that corresponds exactly, but but it is a useful tool. It's a way that with quadratics to still be able to use to be able to factor them even if they don't factor or come out nicely. So yeah, it's kind of a cool new idea that we have imaginary numbers now instead of just real numbers. So over here we have I is going to be the imaginary unit. And the way that I is defined is I equals the square root of negative 1. I equals the square root of negative 1. Which means if we square both sides, that means that I squared, that is going to equal negative 1. I squared is going to equal negative 1. If we square root, we're going to get I equals the square root of negative 1. Excuse me, I got some frog in my throat here. So I is going to be, so either I and I squared are both very important numbers or imaginary numbers for you guys to kind of know. So I is square root of negative 1, I squared is negative 1. Because you square the square root, they're going to cancel out, basically. Okay? It says the imaginary unit I can be used to write the square root of any negative number. The square root of any negative number. So let's get into that here. So if I have, for example, the square root of negative 4, well, I can rewrite the square root of negative 4 as the square root of 4 times the square root of negative 1, right? Because I can split up. 4 times negative 1 is negative 4, so I can rewrite it like that. That's totally fine. And then we can simplify this from here. Now, the reason why this is useful is now we can actually simplify this. What's the square root of 4? Well, that's 2. And what's the square root of negative 1? Well, that's our new definition, which is going to be equal to I. So we get 2I. It's kind of a new idea, but we're kind of introing it this year, so. Okay, let's do another one. Let's do square root of, and they're not actually on the problems here, but we'll still do them. Square root of negative 6. Well, again, there's no perfect square that goes into 6. I'm just going to rewrite it as square root of 6 and square root of negative 1. And in this case, square root of 6 does not simplify at all to a nice whole number, so I'm just going to rewrite this as square root of 6i. Because square root of negative 1 is I. And there's our answer. Okay. So it's a little, foreign, I guess, kind of a foreign idea, but it's still going to be, hopefully it makes sense if you just stick with the definition that I gave you, all right? Let's solve this one. We have x squared equals negative 49, so we take the square root of both sides to get rid of that squared on the x. X is going to equal plus or minus. Well, I can rewrite square root of 49 is a perfect square, so I'm going to rewrite it as square root of 49 times square root of negative 1, because 49 times negative 1 is negative 49. And that's nice because now we can do x equals plus or minus. What's the square root of 49? Well, that is 7, and the square root of negative 1 is I. So our answer is x equals plus or minus 7i. Okay, number 2. We have 2x squared plus 26 equals negative 10. We need to get that x squared by itself. Now, what are we going to do first? We're going to get rid of the 2 or the 26? If it were just 2x plus 26, we would get rid of the 26 first. So we're going to subtract 26 from both sides. So we're going to get 2x squared equals what? Negative 36? How do we solve for x squared now? We're not going to get x squared by itself. So we're going to divide by 2. We're going to get x squared equals, that's going to be what? Negative 18. All right, now we got to split down, a square, 18 here. So we got x squared equals negative 18. We need to take the square root of both sides to get x by itself. So we're going to get x equals. Remember, we got to do plus or minus when we take the square root of an x squared here, or an x plus 3 squared or something. It's going to be plus or minus square root of negative 18. All right, now we got to split this up a little bit. So we're going to do x equals. We got to get rid of that negative under the radical. So I'm going to write square root of 18 and square root of negative 1, because 18 times negative 1 is negative 18, which is good. And then over here, now can I split up square root of 18 to a perfect square? Yeah, square root of 18 is square root of 9 times square root of 2. And then we got square root of negative 1 still. So x equals plus or minus. What's the square root of 9? It's 3. So we got 3 square root of 2. And then that's going to be I. Square root of negative 1 is I. And there's our answer. I usually, when I write my final answers with whole numbers, radicals, and then I kind of go in that order when I'm writing my answers. Okay, you don't go like whole number I and then square roots. We kind of go that direction. All right, sounds good. Moving on. All right, complex numbers. We have, so complex numbers are combinations of real numbers and imaginary numbers. And the way you write them is you write A plus, BI, where A and B are real numbers. A is the real part, and BI is the imaginary part. So we have some examples here. We have 6 plus 5i. What's the real part of that solution? Well, it's going to be 6. And then the imaginary part is going to be 5i. See if you can do the other two on your own here. So the second example there, we have 8i. There actually is no real part there, so it's going to be 0. And our imaginary number is going to be 8i. And then 23 has no bi, so it's going to be 23 is the real part, and 0 is the 0i, that is the imaginary. Okay. All right. So now we can take what we learned. We can actually graph complex numbers. And when we graph complex, this is called the complex number plane. Instead of the Cartesian number plane, where we have x and y, what we're going to do instead, it's going to be kind of a similar thing, but this is the complex number plane. We're going to have real numbers on the x-axis, where that usually the x-axis is, and we're going to have imaginary numbers on the y-axis. Okay? So we have 3 minus 2i, negative 4 plus I, and 3i. So what you're going to treat this is you're going to treat it like it's x and y, basically. So the real numbers are going to be x, this is x, and the imaginary numbers are going to be y. So we got 3 minus 2y. So if, so this would be like we're graphing the point 3, negative 2. Sorry, I hear something over there. So we're going to graph the point 3, negative 2. That's going to represent 3 minus 2i. So we go right 3, and we go down 2. This would be on the complex number plane, this would be 3 minus 2i. That'd be the point right there. Okay? Try number 2 and 3 on your own. See how you do. All right, number 2, we have negative 4 is going to be our x. I is going to be our y. That's going to be the point negative 4, negative 4, 1. And then, so we go left 4, up 1. And that's going to be negative 4 plus I. And then 3i, there actually is no real number. So it's just going to be y. So it's going to be, our answer is going to be 0, 3 for this one. We're going to go up 3. And we get 3i. Okay? So it's a similar to graphing regular whole numbers and stuff, but we're kind of graphing the real part and the imaginary part to make complex numbers, basically, okay? All right, let's keep moving along here. Adding or subtracting complex numbers. What we're going to do here, it's kind of like we're combining like terms. We're going to add the real parts and the imaginary parts separately. Add the real parts and imaginary parts separately. And when you're doing this, you want to make sure that you kind of like distribute negatives and stuff first and kind of rewrite it without the parentheses before you get moving along here, okay? So for number 1, we have 4 plus I plus 3 plus 12i. Well, this is a positive here, so we don't need to change any signs. So we're going to have 4 plus I plus 3 plus 12i. Now we're going to combine like terms. So like terms are going to be the real parts and the imaginary parts. We're going to do 4 and 3 are going to go together. And then I and 12i are going to go together. Okay? So what is 4 plus 3 going to be? Well, that's going to be 7. And what is 1i plus 12i? Well, that's going to be 13i. All right. And that's all you got to do. And then number 2 is very similar. We have 12 plus 5i minus 7 minus 4i. But in this case, we have a negative here. We're subtracting this. So we got to change the signs to both of these. So we're going to rewrite this as 12 plus 5i minus 7 plus 2 negatives make positive 4i. See if you can combine like terms from here. See how you do. All right. Like terms, we got 12 minus 7 and then 5i plus 4i. So 12 minus 7 is 5. And then 5i plus 4i is 9i. And there's our answer. Okay. Moving on to multiplying complex numbers. It says FOIL or distribute and then put in standard form. So standard form is like a plus bi, basically. Okay? So let's go ahead and do this. We have 2i times 7 minus 9i. So we're going to distribute 2i, just like we're distributing. We're going to distribute the 2 to the 7 and 2 to the negative 9i. So what is 2i times 7? Well, that's going to be 14i. 2 times 7 is 14. And then 2 times negative 9 is minus 18. And then I times I is going to be I squared. All right, we're almost there. So we got to do 14i minus 18. Now, what is I squared? If I is square root of negative 1, then I squared is going to be the square root of negative 1 squared, which is just going to be negative 1. So we have 14i. Negative 18 times negative 1 is positive 18. And now we got the right answer. We got to put it with the real number in front. So we're going to have 18 plus 14i. And there we go. All right, number 2, same thing. We are distributing, but we're going to be doing FOIL. We're going to distribute the 7 to the negative 6 and 7 to the 3i. Let's do that first. So 7 times negative 6 is negative 42. 7 times 3i is 21i. Now we're doing the 2i to negative 6, the negative 2i into the 3i. So we got negative 2i times negative 6. Negative 2 times negative 6 is positive 12i. And then negative 2i times negative 3, positive 3i is going to be negative 6. And then we're also going to have I squared. I times I is I squared. Combine like terms. We got these i's here. Not I squared. This is an I squared. I and I squared are different. Remember, it needs to be same variable, same exponent. 42. Negative 42 plus, that's going to be 33i when you add those up. Minus 6i squared. Well, let's actually change that. Let's write I squared is negative 1. Let's just change this to negative 1. So we got negative 42 plus 33i. And then negative 6 times negative 1 is positive 6. Now I can rewrite this. I can add the like terms now. We have the real numbers here. It's going to be negative 36 plus 33i. And there's your answer. All right, complex conjugates. Complex conjugates are in the form a plus bi and a minus bi. So it's basically the same thing. One is plus and one's minus. All right, so if it's minus, it becomes plus. If it's plus, it becomes minus. The product is going to be a real number. So let's go ahead and multiply this. So we'll see why this is important. It's kind of like difference of squares, right? When you multiply a plus b times a minus b, the middles are going to cancel out. So let's go ahead and FOIL this here. So we got 4 times 4 and 4 times 5i. What's 4 times 4? Well, that's 16. 4 times 5i is 20i. And then negative 5i times 4 is negative 20i. You can see those are going to cancel out. Then negative 5i times positive 5i is going to be negative 25i squared. All right, these are going to cancel. They're like terms. And then we have 16 minus 25 times I squared is negative 1. So we get 16 plus 25, which equals 41. All right, so multiplying conjugates are going to cancel, and you're going to be left with a whole number, which is kind of a cool concept and kind of important for later stuff. Okay, moving along here. Dividing complex numbers. Numbers cannot have I, just like radicals, in the denominator. Okay, so we have negative 3. To simplify each of the following, we have negative 3 plus 2i over 5i. And what we need to do is we need to, I'm going to write in this blank here, multiply the numerator and denominator by I. We're going to multiply the numerator and denominator by I to cancel out and kind of have no i's in the denominator, okay? We don't like I in the denominator. We don't like radicals in the denominator. So I'm going to multiply. We have negative 3 plus 2i over 5i. I'm going to multiply both top and bottom by I. Because what does I divided by I go to? That equals 1, right? That's a fancy kind of rule in math. You can multiply by 1. You can add 0. And it will change the problem, but still not be mathematically change it, basically. Okay? So we're going to have to go like this. We're going to have to distribute this I to both of these. So negative 3 times I is negative 3i. 2i times I is going to be positive 2i squared. And then on the bottom, we're going to have 5i squared. And that is going to equal negative 3i plus 2 times negative 1, and on the bottom is going to be 5 times negative 1. Then we get negative 3i minus 2 over negative 5. And then we got to rewrite this with as our answers without like in the correct standard form, basically. So negative 2 has to go in front. Real numbers go in front. Minus 3i over negative 5. And then if you wanted to, the real way to write this, to write it in standard form, would actually be to split the fraction. So this would actually be 2/5 plus 3/5 I would be another way to write that. So these are all correct right here. The negatives all cancel out and they can make a positive basically. Okay? So that's another way to write that. All right, I think this is the last example for today. It is kind of a lot, but you guys are doing a great job, I'll bet. So keep sticking with me here. Okay, it says we have 3 plus 10i over 6 minus 2 minus 6i. And what we need to do, we have a complex number here. We have a real and a negative number, a real and a imaginary number. So we need to multiply by the conjugate. So that's how we cancel stuff to make it a real number. So we're going to multiply the numerator and denominator by the conjugate. Okay, that's going to cancel out the I in the denominator. If you just multiply by I, you're going to get more I's. It's not going to work out. Multiply by the conjugate is how we cancel out I's, basically. So we're going to multiply top and bottom when we have a complex number, that is, by 2. The conjugate of 2 minus 6i is going to be the opposite sign. So it's not 2 minus 6i, it's going to be 2 plus 6i. We're going to do top and bottom by 2 plus 6i. And now this is kind of tricky, because now we have to do this. We have to FOIL all this. We have to do 3 times 2, 3 times 6i, and we got to do 10 times 2, and 10i times 6i, basically. Okay, so let's do that first. So 3 times 2 is going to be 6. 3 times 6i, let's actually go step by step here. We'll go step by step. 3 times 2 is 6. 3 times 6i is 18i. 10 times 2 is 20i. And then 10i times 6i is going to be 60i squared over, on the bottom we're going to do 2 times 2, which is 4, 2 times 6i, which is 12i, negative 6i times 2, which is negative 12i. You see how those cancel out in the middle? And then negative 6i times positive 6i is going to be negative 36i squared. Okay, let's simplify a little bit here. Let's combine some like terms. So on the top, we're going to get 6 plus, these are like terms, 18i, and 20i is going to be 38i. And then we got 60i squared, so plus 60 times negative 1i squared is negative 1. Over, these i's are going to cancel on the bottom. We get 4 minus 36 times negative 1. Okay, keep going. So we have 6 plus 38i minus 60 over 4 plus 36. And then these are like terms on top here. 6 minus 60 is negative 54 plus 38i over 40. Okay, and now we're almost done, but what I would do probably here is I would try to pull out like a factor, a GCF basically out of the top if we're able to. And these are both, these are all even numbers, so I'm going to pull out a 2 on top. We'll pull out a 2, so that's going to, when we divide everything by 2, we're going to get negative 27 plus 19i over 40. And now what we can do is when we pull out a GCF, we can cancel or reduce fractions on the top and bottom. So 2 goes into 2 one time, 2 goes into 40 20 times. So we're going to get, this is going to be equal to negative 27 plus 19i over 20. Or we can, you can write it like that, or you can split it up and write it as an actual, split real number and imaginary number. So negative 27 over 20 plus 19 over 20i, like that. These are our final answers. Okay, pretty tricky lesson. It's really kind of simplistic, but it's also kind of a brand new idea, so give yourself a break if it's kind of challenging. But thank you for watching. Bring your questions to class and have a great day.